Welcome to today's lecture on 3D plotting with MATLAB, where we will explore creating engaging visual representation in 3 dimensions. We will uncover the significance of visualizing data in multiple dimensions, crucial for various disciplines. This session aims to provide a deep understanding of MATLAB's tool for crafting impressive 3D plots, starting with the fundamental concept. Through hands-on exploration with MATLAB functions like meshgrid, plot3, surf, and scatter3, you will gain a practical insight into effective 3D visualization. I encourage active participation in exercises as we unlock the potential of 3D visualization using MATLAB. You can see this is my MATLAB window and all the script we have prepared for 3D plotting. Everything we have prepared in such a manner that the content will be very helpful, very supportive, and during very less time we will cover the entire content which we prepare for you. So before starting the 3D plotting, we need to clear the concept about the mesh grid. In MATLAB, mesh grid is a function used to create a 2D grid of coordinate for Cartesian coordinates. It is particularly useful when we want to evaluate functions or create a plot over a grid of points. So see here we are choosing here two vectors. One is x vary from 0 to 12, and the second we have is y is equal to 0 to 8. So these are two vectors, and when we will convert these two vectors in the mesh grid, and we have the inbuilt function in the MATLAB, which is by using this mesh grid function we can easily convert these two vectors in mesh grid for x as well as y. By using the mesh grid function, we have the equal dimensions for the two vectors. See in the MATLAB, first we need to execute these sequence of statement by press at this place, run the section, and when we will run the section, you can see run this section, and you can see that this is the x and y. X and y both are in equal size. Double click on it to open, and then also open the y, and see the difference between these two. For x is we have from 0 to 12, and the vectors in the first row and the other rows are similar, but the size of this we have is 9 by 13, and the same of that of for y we have is in the first row all the elements are 0, and column wise we have 0 1 2 3 up to 8. So here you can see there are 9 element, and varies from this column to till the 13th column. So by using the mesh grid, we have the both the vectors are converted into the same size of matrices, so that by using the same we can easily plot the graph. So we need to pass these values to plot the graph in 3D. Now see how we can use this mesh grid to plot the graph. Here we have a very simple example, and we are choosing here two input values. The values of x we have is -2 to 2, and step size we have is 0.5, and that of y we have is -2 to 2, and step size here is also 0.5. Now first we need to create the grid coordinate using mesh grid function, and we have the same process. xy is equal to mesh grid, and the values of x and y are passing at this place as argument. And now after creating this mesh grid, we need to pass this mesh grid through the z function, and we have is z is equal to x square plus y square. Okay, and the argument the values which are stored in mesh grid will pass through at this place, and we will calculate the values for this mesh grid. Now we have the function surf. So by using the surf function, this will generate the surface of the function, and x and y, these are the input argument, and z is the output function. Okay, z will depend upon x and y. So this will generate the surface of the function, and then we can assign here x label, y label, and z label. You can see x label we have is x-axis, y label we have is y-axis, z label we have is z-axis, and then this will add the title of the function. And when we will execute this sequence of statement by press here, and we can see that we have this very beautiful graph which is in 3D. If you want to add here, like you can add here grid on, then you can add box on. So again, build the file, and you can see that here grid. So I have to correct this statement. Yes, grid on and box on. Now run the file, and you can see that we have box is on. In the previous we don't have the box, but right now you can see that on the top we have the title of the graph, and on the horizontal line we have x-axis, and on the left hand side we have y-axis. On the vertical left side we have z-axis. So in this way we can easily insert these dimensions, and further if you want to manipulate or customize, we can do easily as we do in the first lecture based on 2D plotting. This is one more example here, and we have the plot3 function we are using to plot the function. So here you can see we have the mesh grid, and the dimension is -3 to 3 for both x and y, and this is the required function. Z is equal to, we have is x dot product exponential minus x square minus y square. So here some more statements are used at this place, and the purpose of to use this statement is just when we will plot the graph, this will open in full size, as much as the size of the screen. Okay, and here this is the statement, screen size get 0 screen size, and next we have the set GCF position screen size. So by using these two statements, when you will execute, the image which one will open will be full screen size. Now here we are using the plot3 function for x, y, and z. X, y are independent variable, z is a function. And here you can see the grid on, box on, x label, y label, z label, all these are also added in this image. So when you will execute this sequence of statement, and you can see that the image is opened in full size, along with the on the horizontal plane we have, on the left side we have, right side we have is x-axis, on the left side we have is y-axis, and on the vertical line we have z-axis. Similarly, you can come to the third example, and in the third example we have is we can use plot3 function, mesh function is also there, surf, contour, surface, ez plot. So all these we can discuss and we can use for the 3D plotting. But here we have t is 0 to 10 pi, and the step size we are choosing at this place pi upon 70. Okay, so this is the step size, and we can manipulate it as 100, pi upon 100. This is the step size for this interval from 0 to 10 pi. And these statements are similar as we discussed in the previous one to make the full size output. And here you can see we have a parametric equation, and plot 3 here is sine t, second we have is cosine t, and last one we have is t. So this is the x is equal to sine t, y is equal to cos t, and z is equal to t, and the other we have is grid on, box on, axis square. This will the dimensions will be equal. X label, y label, z label, and title also has been added in this image. When you will execute this sequence of statement, See here what happened, and you can see we have this very beautiful graph in 3D, and box is open, box is there, and dimensions are there according our input. Similarly, we have the next most interesting example, and here we can also use our customize or user defined function, and these are the some syntax which will help you to write the code. Okay, and here you can see this is the x vector, this is the y vector with the range -2 to 2, and here we are generating the mesh grid in the same way, and z is equal to, we have this function, and function is x dot exponential minus x square minus y square. These are the same to make the full size of the image. Okay, and surf function we are using here. So the surf function will generate the surface of this function, and the other inputs you can see the x label is there, y label is there, z label, grid, and box on. And when you will execute this sequence of statement, we have this is the surface is generated here. And also one more thing, when you will you can see here there are some icons, and when you will choose this one, rotate 3D, and now come to on the screen and left click, and now you can rotate this 3D plot in any direction. You can rotate this image in 360 degree. Yes, you can rotate in 360 degree, and after fixing the position which is according to your desire, and then you can export by pressing Ctrl and S. This will save the image in your current directory, and I am using here figure. This is figure 1. Okay, and output format is .jpg. Save it, and you can see the image is saved in our current directory. Here is the image, figure 1. Similarly, we can have the third one more example, and here is x equal to, we have this range line space we have is -2 to 2, and that of y is also same. Then we need to generate the mesh grid. This is the z function we have is sine x plus y dot product log x square plus y square, and these are the same statement, and here we are generating the surface for the same surface x comma y comma z, and these are the same statement, and along with we have the color bar. You can use color bar also in the graph. So when you will execute this sequence of statement, and you can see we have this graph, and on the right hand side you can see the color bar also. Okay, and you can rotate this diagram also in any direction, and when you will make in this way, you can see there is in the center there is small hole. At this point the function does not exist, so this is the not part of this graph. So here you can engage this diagram in any direction by rotating in this way. In the sixth example, we have the function. This is the similar type of the example, only the function we change at this place, and these are the x input, y vector, and mesh grid, and the function we have is z minus x square minus y square. These statements are similar, and here we are generating the surface, and the thing is that here we have two surfaces. One is this function, and the second we have is this function. So if you want to combine the two surfaces in a single plot, you can do in this way, and you will use here hold on function, and you will put as the new function, and the surf function is used here to generate the surface for this function. Okay, and hold off, then box on, and other statements are here, and also you can insert x label, y label, z label. And see carefully, we are using here legend. Okay, so for the two different surfaces we have to use legend at this place. When you will execute, you can see there are two different surfaces. One is on the top and the other is at the bottom. Both are combined in the same plot, and color bar is there. Along with you can see a legend. This is the legend, and the first in the yellow color we have the Z surface, and in the blue color means at the bottom we have the W surface. So in this way, by using these sequence of statements, sometimes we need to merge two surfaces in the single plot, and this is very quite easy to combine two surfaces in the single plot. Here we have one more interesting example, and the example is that we are choosing at this place mesh grid, and this is the another way you can use. This is the x and the other is y minus 1 to 1, and these are the statements. But here the function is we have this is the surface xy, x square plus y square, and subplot 1 to 1 and other is 1 to 2. So two graphs we are plot in the single graph, and here the other part is contour. So contour also is there for the contour graph, and we want to plot the contour for this function. X input is there, y input is there, and the function is x square minus y square. Okay, and the numerical value can be increased for the contours. We can manipulate according to our desire. And the other statement, axis square, grid on, box on. Okay, so axis will be equal when you will use axis square, and plot the graph. You can see on the left hand side we have the surface, and on the right hand side you can see the contour graph. So both are appeared in the single plot. In this way you can combine, you can use, if you have more subplots you can manipulate accordingly. This is the eighth example, and in this eighth example we have three surfaces are there. You can see we have three functions, and these three functions will generate three surface. But the most important thing I let you know, the input must be equal for these three functions, and that's why we generate at this place mesh grid. Okay, and these will pass through these three functions, and this is the similar statement we are using here. So this is the surface for the function z1, x comma y comma z1, and box on and hold on. Okay, then we will plot here a surface z2, surface z3, and hold off. Okay, and here you can see the x label, y label, z label, and legend is also mandatory to introduce here, because we have three surfaces, and with the help of legend we can easily recognize the surface for these three different functions and grid on. Okay, when you will execute, you can see we have these three surfaces, and in the on the top you can see the mesh grid. Darkest blue is z1, so at the bottom we have the z1 plane, then we have the z2 plane, and at the top we have z3 plane. So here you can easily observe three surfaces, three planes are there, and you can easily rotate in any direction, and you can see three different graphs, and two are intersecting with each other. Two planes are parallel. Okay, so these two planes at this place you can see which are intersecting. Okay, so in this way you can easily go through and you can check these 3D plots. Now in the ninth file, we have one more interesting function here, and but we are generating here mesh plot. Here is mesh function we are using, and this is the grid, and z function which we are choosing at this place we have is 70 y square exponential minus x square minus y square. Okay, these are the same statement, we don't changing here, but the function at this place which we are using mesh x y z, and the other statements for x label, y label, z label, grid on, box on are similar. You can execute, and you can see here we have the mesh plot. This is the mesh plot. If you change this mesh into surf, if you change here mesh into surf, and then we have this image. Okay, so in the previously we have the mesh, but here you can see this is the surface of the function. So this is the difference only. Sometimes it is required mesh graph, sometimes we need surface graph. So according to the need, we can easily manipulate. Here we have one more example which will introduce here the graph in we have the same graph x z is equal to x dot exponential x square plus y square, and here we have the subplots. In the first subplot we have the surface and axis square box on. In the second we have the mesh plot, axis square and box on. In the third we have is contour and box on. In the last we have surface. Surface will return the plot, surface and contour together. Okay, so when you want to present your graphs in the matrix format, so matrix is 2x2 order, but the one is top left image, this will return as a top right image, this will return bottom left, this will be bottom right. And when you will execute this sequence of statement, see we have, you can see the images, the plots in the single file according to our input. This is the top z1 function, this is the z2, this is the z3, and this is the z4. Further, if you want to manipulate, you want to insert a title, you want to insert x label, y label, z label on each, you can easily manipulate them. And in the last file, this is the 11th file, and you can see here we have the function is x is equal to sine t, y is equal to x is equal to cosine t, y is equal to sine t, z is equal to t. Okay, and sims t, here we are using symbolic mathematics. Okay, and along with the, here is f plot 3. In the old version of the MATLAB we have ez plot 3, but now in the latest version which we are using MATLAB 2020 or 2022, in these versions after MATLAB version 2015, we are using this f plot 3 function in the place of ez plot 3. Okay, and you can see here just we need to give the input x, y, z, and the parametric range of t we have is 0 to 2 pi, and the other we have the x label, y label, z label. You can insert the title, grid on, box on, and when you will execute, you can see here is the curve in 3D. So this is the 3D plot. Okay, you can again rotate in any direction. The rotation is possible for 360 degree. In this MATLAB lecture on 3D plotting immersed us in the world of dynamic data visualization. We explored crafting engaging visual representation crucial across diverse fields. MATLAB's tool like meshgrid, plot3, surf, and scatter3 were central to our hands-on learning, offering insight into creating clear and impactful 3D plot. Your active participation showcased dedication, and I encourage ongoing practice to unlock the full potential of MATLAB's visualization capabilities. For further assistance or question, feel free to reach out as we continue our journey in mastering 3D plotting with MATLAB together. Thank you very much to see this lecture till the end.